Hey guys, today we are talking about kinematics. Introduction to kinematics. Kinematics is the mathematical treatment of the motions of bodies without regard to the forces that produce the motion. So, why do things move? We'll answer that question later. For now, we know things can move, so let's talk about what causes their motion. To really understand how things move, we need to look at two different values. Scalar quantities, scalar values, and vector quantities, vector values. Scalars and vectors are two different types of measurements. A scalar quantity has magnitude, but no direction. Magnitude tells us how much we have, or how much there is. Okay? For example, the odometer in your family car tells you how fast the car is moving, but not the direction it is moving. Therefore, the odometer is telling you a scalar quantity. Scalar, no direction. For example, it tells you 45 miles per hour, that's mph, but not 45 miles per hour east. Right? No direction there. If you get lost, you better have a GPS. Here are some examples of scalar quantities. Okay? We have distance, time, speed, mass, temperature, and energy. And to really understand each of these measurements, we're going to need to take a look at the units we use. The standard unit we use for distance is the meter. Now, you might be used to using inches or feet or miles. Those are all part of the English system. That's what we use in this country. But the conversions between each type are very complicated. All right, there's a lot of different numbers to remember. We're using only the metric system. Using only the metric system will make everything much, much easier for us. All right, so the meter is the unit that we'll use for distance. The unit we'll use for time is the second. You guys know what seconds are? You're probably counting seconds right now. Seconds is what we'll use for time. Speed is a combination of the two. Speed tells us how many meters we travel in a second. So speed is meters per second. Right? That word per just means divided by, m/s. All right, those are the big ones that we'll look at first. I'll let you in on a little secret. The unit that we're going to be using for mass is the kilogram, abbreviated kg. Mass in kilograms. Something that's about a kilogram is, let's say, like one of your notebooks. Depends how big it is. Temperature and energy we'll get to later. Temperature is a scalar value, measures how much heat we have. Energy we're going to get to in its own separate unit. So we'll leave those alone for now. Now, scalar quantities, again, have no direction. So, the big difference between scalars and vectors is vector quantities have both magnitude and direction. Okay? Vector has both magnitude and direction. For example, if you ask directions to the beach in a foreign country, a citizen may tell you 50 kilometers east. This is kilometers. The citizen has given you both a magnitude, or numerical value, and a direction, north, south, east, or west. Okay, so some examples of vectors. We have displacement, acceleration, force, momentum, and electric force, magnetic force. Let's take them one at a time. Displacement is a lot like distance. It tells you how far away something is, but it also tells you where it's going. So displacement is also measured in meters. It also happens to give you the direction. Could be north, south, east, or west. You could even go up or down. All right. Displacement is kind of like how far away you are from your starting point. So if you walk 5 meters north, you're 5 meters away from your starting point when you stop. Acceleration is the rate that velocity changes, Acceleration is measured in meters per second squared. All right, it's related to velocity, but it's a little bit different. It's kind of the rate of velocity change, but we'll get into acceleration in a later packet. Force, a lot of people know the unit already for force. Force is measured in newtons. You guys know Sir Isaac Newton is the first person to talk about forces. And in physics, if you discover something important or you're the first to coin a new term, like Newton did with force, you get the unit named after you. So newtons of force, we use capital N as the symbol. All right, now the nice thing about all forces, take a jump down to electric force and magnetic force, doesn't matter what creates that force. A force is a push or a pull. Okay, and you can see a little diagram here. This is a vector, this arrow. An electric force is created from some kind of electric charge or electric current. A magnetic force is like the magnets on your fridge, the forces that they produce. These are all using the units newtons. All right, any force is measured in newtons. The last one here, momentum. Momentum is another one we'll get into the units and the information later in a later packet. But momentum for now is measured in kilogram meters per second. All right, looks like a little hodgepodge there of units, but that's what it is. All right, so scalars have no direction. Vectors have magnitude and direction. All right, so let's flip on over to the back of this page here. All right, and let's start looking at each of these and determine if they're a vector or scalar. So I'm just going to write V or S, vector or scalar. If you look at A, 40 meters per second east. This east is a direction. That alone is enough for us to identify it as a vector. So A is a vector. Now, 40 meters per second. This value right here, this is our magnitude. Okay, so our magnitude is circled here, 40 meters per second. East is underlined, this is our direction. Okay, the type of unit you have, this meters per second, that tells us the type of measurement we're making. Since we already know this is a vector, the vector quantity that uses meters per second, it wasn't on the last list, but this is a velocity. How fast something is traveling with the direction. Okay, let's go down to B. B is 30 meters. There's no direction there. There's no north, south, east, west, up, down, left, right. It's missing. All we have is this 30 meters. That 30 meters is a magnitude. It's an amount of distance. So this is a scalar quantity measuring distance. All right. 40 degrees Celsius, I'm sure you are used to seeing that one already. That's temperature. Temperature is a scalar value. Okay, there's no direction. If you can go 40 degrees Celsius north, I'm impressed. D, 20 kilogram meters per second. 20 kilogram meters per second is a scalar value. This is the magnitude, excuse me, not scalar. This is a vector. Northeast shows us direction. Magnitude and direction. This is a vector quantity. Kilogram meters per second was our unit for momentum. All right. Next one, 25 newtons. This one confuses a lot of folks. Remember, newtons are a measure of force. So we know that this is a force. All forces are vector quantities. Vector quantities or vector measurements. All right. Quantities and measurements kind of like the same thing here. Let's go down to the next piece. All right, part F. We have 25 newtons west. So again, we have a magnitude and a direction. This is still a force. this is still a vector. Okay, just a little bit extra information, this specific direction that this force is pushing or pulling. All right, for part G, G is distance. Distance is a scalar. Displacement is very similar to distance. They both measure how far something travels, just in slightly different ways. Displacement is a vector. Okay, moving on to letter I. Velocity, how fast something travels, with a direction is a vector. J is speed, how fast something travels without a direction. This is scalar. And finally, K is momentum. Momentum we have defined as a vector. All right, guys, so that is our little introduction to scalars versus vectors. Biggest things to remember, scalars are magnitude only, and vectors are magnitude and direction. Okay, if you know direction, chances are you have a vector. All right, guys, nice job today. Talk to you soon.